This is Kyle Dunsmore and Joe Dixon from SC4. This is our digital logic circuit. Here you can see the Boolean equation that we're given for our circuit. Here you can see where we simplified it down to a simple equation. Over here you can see where we worked it out in a truth table. And there's only 3 times where the circuit is logically true. Here you can see our K-map that we drew of those truths. This is our logic circuit. You can see in order for it to become logically true, we need A and D and B, and it becomes logically true. Or we need D and not C, and we need B, and this will become logically true and the LED will turn on. We have the circuit itself. We have our inverter chip. This is our AND chip, and this is our OR chip. So you can see if we turn on 1, 2, and 4, our LED will light up. For the bottom half of our logic to be true, we need 2, not 3, and 4. And you can see the LED will light up. And because this is an OR gate, we can have 3 if we have 1, because then the first part of our circuit becomes true and the circuit will work.
So a bug we were given for a circuit was a loose connection to ground. How we fix this, we asked some very good questions of, what we were doing when it stopped working and if you heard anything. He said he heard some vibration, and that could be a sign of a loose connection. He also noted that he tried to tighten this ground terminal. Once we took a closer look at it, we realized that the ground was not actually having a good connection, so it was not giving us an output even though all of our inputs were high. So when we take that ground and put it back in so it's got a solid connection, our output comes back on and our circuit is working perfectly fine again. So right here we have our digital representation of the circuit. On the left side here we have our original equation in the circuit. So we have 3 different sets of the equation, all going to OR gates, giving us our output. And then on the right side we have our simplified equation going to 2 sets going into 1 OR gate, giving us an output. And on the very bottom here we have a very simplified version of the circuit. 2 equations, 1 OR gate, going to 1 output. This has been Kyle and Joe's Boolean equation digital circuit. We hope you enjoyed. If you have any questions, leave them down below. We'll be sure to answer those as soon as we can. And as always, thanks for watching. See you in the next one.